What I will show here is a complete domain takeover by a payload delivered to an ordinary user in a Windows Active Directory. It could be delivered by email, the payload will now connect the reverse shell back to the attacker. The attacker could now upload a reverse proxy client to the victim's computer. The proxy server will now give the attacker full access to the internal network as the logged on user. He can now coerce the domain controller to authenticate back to him, then relaying that authentication to the certificate server, asking for a domain controller certificate. The attacker will then get a certificate and can act as a domain controller and ask for a ticket granting ticket. He will receive a ticket granting ticket when he authenticates with the certificate, and he will use the ticket granting ticket to do a DCSync. He will then receive all the usernames in the domain with their NT hashes. I will now show this attack in detail. First, we will generate the payload. We will here use a LNK-file. I will use my script for generating reverse shells to generate a PowerShell reverse shell. Then we use LNK to pawn and put the payload in the arguments field. Although the arguments field only can show 256 characters, it can hold a lot more. We try to hide our payload by inserting 256 white spaces. That way it won't show in the properties window of the LNK file. Then we load icon from index 70 from the shell 32.dll, and we give the document a name with a fake extension of .txt. Then we save the payload. I save it here on my desktop. Then I open multiple terminal windows that makes it easier to see what's happening. We're going to connect to a server I have on the internet. I put the payload on the Windows computer. I'm just going to paste it in there now. If we look at the properties, we can now see as we use 256 blank spaces, it won't show up. Then we start a netcat listener on the server and start the payload. We now have a reverse shell back to our attacking computer. We will now start chisel the reverse proxy server on our server attacking computer. We'll start it with a parameter backend and point it to the loopback address of our attacking computer. Then we'll start a Python HTTP server listening to the loopback interface and serving our tools directory. Next, we use the PowerShell invoke web request cmdlet to download the chisel proxy client to the victim's computer. Then we'll use the start process cmdlet in PowerShell to start a new instance of our proxy client so that we'll not lock this reverse shell with a session. and we can see the client is connecting back to us. Next thing we'll do is to configure proxy chains to go through our proxy tunnel. Then we'll generate a new reverse shell. This time we will activate full embedded AMSI bypass in that shell. Then we'll make ourselves a PowerShell script. We call it make task, and we paste our reverse shell payload into the script. This script will make a new scheduled task that will execute our reverse shell payload. We set the task to trigger each minute, and we give it a name. Here we call it OneDrive Reporting Cleanup. And save it. And then we use a invoke expression download cradle to download the script and execute it in memory. As we have used a AMSI bypass, it won't be detected of any antivirus. We then exit our reverse shell and wait for a new session to come back to us, this time with a full AMSI bypass. Again, we will use a download cradle to download and execute invoke Rubius in memory on the victim computer. Then we'll use Rubius TGT delegate to get ourselves a ticket granting ticket for the user we are logged in as, which is Aaron Simmons. It will be presented in a base 64 format to cope with that TGT and save it on our attacking computer. We'll now need to set up the Kerberos client on our attacking Linux computer. For doing that, we need some information, so we use a klist on the computer we have access over to get information needed to create the Kerberos configuration. Here we can find the key distribution center, which is a domain controller. And we can also see the Kerberos realm, which is wincorp.htb in capital letters. Put this into our Kerberos configuration file. Then we need the IP address of the domain controller. And we edit our hosts file to add the IP address of the domain computer and the domain. Then we export the environment variable for the Kerberos configuration. I do this in both terminal windows because it's local to the terminal. Then we decode the base64 encoded ticket to a binary Kirby format. And we use ticket converter to convert it to Zcash format, and we export it so that the Kerberos client on our attacking computer can find the ticket counting ticket. We use the klist command to see that the ticket is loaded. And now we can act as the user Aaron Simmons on the domain. Then we start in packet NTLM relay X through proxy chains, pointing it to the certificate server and asking for a domain controller certificate. Our relayer are now waiting for connections. Now we need to coerce the domain controllers to authenticate to us and then relay it to the certificate server. And there we got the domain controller certificate. It is also base 64 encoded. We copy it and save it to a file on our attacking computer. We will now use getTGT PKI init to authenticate to the domain controller using the certificate and ask for a ticket granting ticket as the domain controller. We got the TGT and it is saved to a file. We now load that file into our Kerberos configuration. And if we start klist, we can see that we have loaded the ticket granting ticket for the domain controller. Then we start in packet secrets dump through proxy chains to request a DCSync as the domain controller. And after a short while, the usernames and hashes start raining in. If we scroll up, we will find the domain administrator's NT hash at the top of the list. We copy it and we use evil winrm through proxy chains to log on to the domain controller as the domain administrator. But for this to work, we rely on that 3 ports are open in the company's firewall: TCP/80, TCP/443, and TCP/445. TCP/445 is the SMB protocol and should be blocked. Corporate computers should not access the internet with the SMB protocol. So let's say that this is the case here. We still have our reverse shell and our reverse proxy running because they only use port 443 TCP and port 80. We again load our user's ticket granting ticket. Then we use in-packet add computer to add a new computer object to Active Directory with a password we know. As default, every user are allowed to create 10 computer objects. Then we use in-packet get tgt to request a ticket granting ticket as the computer we just created. And we load the computer into Kerberos configuration and check it with klist. Then we run certutil on the victim computer to find the name of the certificate authority server. And we need the IP address of that server. Add it to our hosts file. And run certify. And we request a machine certificate from the machine template. And we have a computer certificate. And we use DNS tool to add a record pointing to our IP for that computer object. Then we unpack the PFX file we got from the certificate server containing the computer's certificate and private key and split them into 2 files. Then we need to expand the UDP buffer size and use the SMB or QUIC utility. This will load our certificate and private key so that the domain controller will have a trusted connection. Then again, we will do NTLM relay X. As I said earlier, this time port 445 TCP is blocked in the firewall so the server cannot reach us. But the trick here is that it is a 2022 domain controller, and when it cannot contact us on port 445, it will fall back to using UDP 443, which is the new SMB VPN protocol that Microsoft have implemented. And again, we will receive the certificate, and we can do the same thing we did earlier. So to recap, this time we are using also three protocols. We are using port 80 TCP for our reverse proxy connection, and we are using TCP 443 for our reverse shell, and we are using port 443 UDP for our SMB traffic. And port 443 UDP is seldom blocked in a corporate firewall. Once again, we use in packet secret stub to request a DCSync, and we will receive the usernames and their NT hashes. And just as the last time, we find the domain administrator's NT hash, we copy it and run winrm through proxy chains and use pass the hash technique to log on to the domain computer as the domain administrator.